We're going to get underway now. My name is David Caroli, and I'm an honorary professor here at the University of Melbourne and a part of the Climate and Energy College. My main job is as leader of the Earth Systems and Climate Change Hub, for which the University of Melbourne is one of the partners, but I'm employed by CSIRO down in Aspendale, having been at the University of Melbourne for a substantial period of time, 11 years, and then for the most recent 1 year at CSIRO. It's my pleasure today to welcome you all here for Myles Allen's seminar. Before we get to that, I have to go through the official safety announcements, and that is that the fire exit is carefully hidden behind these banners, and the fire exit is there. And you can use that if there is emergency alarms, and I believe you are also allowed to just go to those doors as well. But I'm anticipating no emergency exit being needed. I also would like to recognise the traditional owners of this land on which we're holding this seminar, the Wurundjeri people of the Kulin Nation, and pay my respects to their elders, both past, present, and emerging. It's really important in the context of talking about climate change to recognise that the traditional owners of this land survived massive climate change from the last ice age to a substantial warming in the current period over thousands of years. Myles will be talking about how to potentially avoid larger climate change over shorter periods, or how to potentially avoid that. It's my honour and pleasure to welcome Myles, who I have known for a substantial period of time, and we've even co-authored a few papers together. Myles is Professor of Geosystem Science in the Environmental Change Institute at the School of Geography and the Environment at Oxford University, as well as having a position in the Department of Physics. He has a diverse range of research interests in both climate change and extremes and the causes of climate change, as well as the solutions of climate change. He was a coordinating lead author in the report last year, the IPCC special report on global warming of 1.5 degrees. But that wasn't the first time he was involved in IPCC. He was involved in IPCC, I think, for the first time in a chapter that I might have been coordinating lead author of. That was way back in 2001. But he also was involved in the 4th assessment report and the 5th assessment report in lots of different things. And he's also co-director of the Oxford Martin School Net Zero Carbon Investment Initiative, and is particularly interested in, if you like, investments and financial institutions and their role in limiting greenhouse gas emissions. I look forward to your talk, Myles.
Thank you, David. David and I probably have known each other for, sorry, I should switch this on. Probably known each other for about 1/4 of a degree.
I think
a third of a degree, probably a third of a degree. Slightly depressing way of measuring time these days. I'm simply standing over there. Okay, that's
I can do this.
Well, we'll do that. Okay, right.
This is tag team talking.
Okay, right. Hello, whoever is able to see me. Right, I shall try and remember. Okay, thanks, David. Is that all? Can you maybe move a chair down?
Yeah.
Okay. Right. Okay. So that's the title, and actually earlier today, David and I, important stress, David was on his lunch break and wasn't striking, nor was he speaking to the public as an employee of CSIRO. We were down at the school strike in central Melbourne, and it was really interesting to see the passion and enthusiasm there, and it actually did really strike me that the difference between demonstrations on climate here in Australia compared to demonstrations on climate in the UK is that here actually people have got to ask. There's actually things people want changing, and there's also demonstrations on climate in the UK that it's always like climate action. And they, well, what? Whereas at least here there's fairly specific demands on the placards, which is so. Yeah, there are some advantages to being in Australia on the climate issue. Anyway, so okay, so I want to talk about this, and the subtitle here, of course, might have been seen as slightly odd for many of the people demonstrating, many of those holding the Darling Mine placards down at the demonstration. But let's see what I can convince you about this. So, 3 questions I want to talk about. You know, the question, first of all, are we nearly there yet, and what it'll take, and how fast can we actually stop global warming? I'll sort of digress briefly on something you might call social geoengineering, or some of these hyper-ambitious mitigation scenarios that have been assessed in the 1.5 degrees report, and which I think carry their own dangers. And we need to think about those, because I'm assuming a sort of self-selecting group of people that attends a talk on climate change has a particular set of views on these things. You know, I think it's important to consider the downside risk of over-ambitious mitigation scenarios. Not over-ambitious mitigation itself, there probably aren't very many downside risks of that, but some of these scenarios actually have a downside risk. And then this third question is sort of how the fossil fuel industry itself could play a role in addressing climate change. Let's keep going. This is one of the figures. Actually, it's not that visible on this screen, so let's just move straight on from the 1.5 degree report. I'm going to talk about sort of where we are now on the climate issue and how close we are to 1.5 degrees, and some of the evidence that we assessed in the 1.5 degrees report. If we go straight on to the next slide, David. This shows you the contributions to global temperatures. The grey line is observed warming, monthly temperatures over the past century. This goes back to 1850. You can see that in 2016, one of the data sets wobbled over 1.5 degrees for about a month. So it's important to, one of the tasks we had in the IPCC report was to clarify what was meant by global temperatures exceeding 1.5 degrees. Because although that was the wording in Paris, agreed by the governments that we would limit warming to well below 2 degrees and pursue efforts to 1.5 degrees, they didn't actually say what they meant by an increase in global average temperature. And so one of the tasks we had in the report was to put some precision on that. And clearly a single month wobbling over 1.5 degrees didn't seem to us to be a reasonable interpretation of the Paris goal, although governments had views on that. And we interpreted it as the long-term temperature trend exceeding 1.5 degrees permanently, as it were, sort of moving past 1.5 degrees. And that's illustrated here by the thick orange line, which shows you our estimated response to anthropogenic drivers of climate change over the past century. The blue wiggle shows you the estimated responses to natural factors, solar activity and volcanic eruptions. And this is just using the kind of detection attribution algorithms that David played a big role in developing along with others back in the 90s, just to estimate how big these different drivers are in the observed record. Importantly, we don't use climate models to work out how much of the observed warming is due to human influence. We estimate that from the data, and therefore when the IPCC report says, as we do on the next slide, that human-induced warming has reached 1 degree with an uncertainty range of plus or minus 0.2 degrees, that's a statement about the observed warming and what it can be attributed to. It's not a statement about what climate models do. It's not dependent on the climate model responses. The fact that we're at 1 degree and warming at 0.2 degrees per decade means you don't have to be a mathematical genius to work out that it won't be very long before we reach 1.5 degrees. Given the uncertainties in that, there's obviously a risk that we'll reach 1.5 degrees really quite soon. In fact, if we go to the next slide, that's 1 degree. This is back to that, yeah, thanks. This is back to, no, previous one, okay, let's follow the punchline. But no, it's the next one. Thank you. Okay, you're gonna get 5 in a minute. Okay, and if you take one more, just one, Perfect. Okay. So this shows a zoom in of one of the figures in the summary for policymakers, which shows you observed global temperatures to date and just extrapolating the current rate of warming, showing you when it reaches 1.5 degrees. And the summary statement is that, which and we ended up with in the 1.5 degree report, is that global warming is likely to reach 1.5 degrees somewhere between, likely means there's a 2 in 3 chance in IPCC jargon, between 2030 and around 2050 if it continues to increase at the current rate. That's, you know, a lot of people latched onto that. If we go to the next slide, and so this isn't actually a demonstration, but it was a demonstration a few weeks ago in the UK, one of these school strikes for climate, and I picked up this photo because there's quite a lot of these placards have 12 years on them, and that's quite a common theme in coverage of the IPCC report, which is, you know, 12 years to climate chaos, or this one is 12 years before the planet bursts into flames, and that 12 years comes from that 2030 and in fact, as I got off the tram this morning, I actually heard some students talking about 12 years to save the planet. I was tempted to say, actually what we said was, it probably would have hit me, or suspected me of being an agent of a dummy or something. Anyway, but it is a worry because, of course, the only way you get to 1.5 degrees in 2030 is if we're already at 1.2 degrees, which we might be. You know, we allowed for that uncertainty, and we're warming at 0.3 degrees per decade, so at the top end of the range of uncertainty in the current warming rate. Put those two things together and you get to 1.5 degrees before 2030. But of course then that's only an additional 0.3 degrees of warming above where we're at now. So it's probably not what people think is meant by the additional impacts of 1.5 degrees. So you have to put a lot of things together to get there that fast, and then you end up in a state which isn't, you know, the planet in flames. So, so the danger with this, of course, is saying, you know, we've got 12 years to climate chaos. If you go to the next slide, first of all, we don't have 12 years anyway. I mean, there's plenty of bad stuff happening, particularly in Australia already. Never mind, you know, waiting for 12 years. But the other side of this, you go to the next slide, is that headlines like this, which is from a British paper, Daily Mail, but I'm sure you get similar sort of headlines around here. Doomsday prediction for surging tides was wrong. Study claims yada 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 will be responsible for 6-inch boost in sea level 7 times less than previously thought. If we go to if you drill down in this article, you find the latest study found that by the end of the century, global sea levels will rise by a grand total of less than 4 feet, less dramatic than the previous prediction of 6 feet. Okay. But that was picture number 4 in the article. Okay, the only people who actually saw was the headline, and the guys writing these articles, they do understand it, because if you actually look at the numbers, they have worked it out. Which number can I use to give me a factor of 7? They picked it out very carefully and constructed the article accordingly. There's a special place in hell for these people, I'm sure. But the point is, you know, and I don't care which side they're on. It's that clever manipulation of numbers to give a particular message which you must know is misleading, because nobody who didn't understand the actual study would have known and taken the trouble to manipulate the numbers in that way. So, if we start saying now, sorry, is a representative of the Mail online?
No, I was just saying that anybody who deals with the Mail online literally needs to have their heading down. Because they tend to do sensational stuff.
Of course they do sensational stuff, but the point is that somebody spent quite a long time bleeding through those articles to get 2 numbers that they could take a ratio from to get a number, you know, a factor of 7. And the point is that this is happening. And I don't need to tell you this, you all know it's happening here as well. And if we start saying things like 12 years till climate, or IPCC says 12 years till climate chaos, you can bet your life there will be people still in 2030, when it's only 1.25 degrees or something above spring, which is actually what the IPCC is predicting, saying IPCC forecast was wrong by a factor of 2. And you know, we therefore got to be more careful in how I think collectively we all have to be more careful in how the IPCC findings are communicated. If we go to the next one, this is just an example of it. You know, this whole rhetoric of climate emergency. I've been asked a lot to talk about climate emergency since the 1.5 degrees report, and often get asked, you know, was the 1.5 degree report the sort of starting gun on climate emergency and what's kind of discussion? And I, you know, it really worries me, this climate emergency framework. Yes, there's enormous urgency about this. As David pointed out, it's actually a much better analogy. You've got a lava flow coming down towards your village. Okay, yes, it's an emergency, but it's not happening very fast. But you know, when it gets to the village, it won't be very pleasant. So that's a much, you know, that's much more akin to the situation we're in. And I wish some of the communicators who are engaged with the climate issue were a bit clearer in communicating that situation, that situation to many of the young people who are concerned about it. Here's just an example. You won't be able to read the little tweet from Tom Elliott, who tweeted, well, like, the world is going to end in 12 years if we don't address climate change. And Alexandria Ocasio-Cortez, who's the US Congresswoman who's really making climate change her signature issue, gave quite a clever tweet on top of that, saying the UN says we've got 12 years left to fix it, which of course is different from saying the world's going to come to an end in 12 years if we don't fix it. So she sort of echoed it. You know, she's almost playing the same game as the Mail on Sunday reporter, in that she's using the 12 years, okay, so she's sort of being friendly, embracing what the millennial tweeter was saying, but not actually saying, no, that's wrong, but this is what you can say. And I think there's communicators who've got the attention of the world on this need to be more careful and straight with people, actually, on exactly what can and can't be said. Let's keep going. So what can we say robustly, based on what we currently know, that isn't sort of a hostage to fortune, that isn't, you know, pushing the evidence in any particular direction? So, you know, if we're now at 1 degree, warming at 0.2 degrees per decade, actually slightly over 1 degree, slightly faster than 0.2 degrees per decade, put that together, we've got about 20 years before we'll get to 1.5 degrees at the current rate. That's the best estimate, not one end of the uncertainty range. This shows you the same kind of data which was shown in the SPM. It's, you know, there's the observations, there's our estimated total human-induced warming, and the red line here is the contribution of CO2 to that warming. So the total warming is quite a lot bigger than the CO2-induced warming because other gases are playing a role as well. Methane is the big other contributor. So that's where, you know, we're at in terms of human-induced warming. And if we put that a different way, so this is showing you the same data, just plotted differently. Go down. That's the paper this comes from. This shows you the rate of human-induced warming. So it's just the time derivative of the previous graph. And you can see, soberingly, human-induced warming is currently rising at its fastest rate ever, over 2 degrees per decade, to 0.2 of a degree per year. And if we're going to limit future warming to 1.5 degrees, we have, as a matter of geometry, to bring that rate of warming to 0 in a relatively small amount of time. If you just hit return. This triangle here shows you the climate braking distance. If you think back to learning about braking distances for your driving test, remember a car driving at 50 miles an hour has one braking distance, a car driving at 70 miles an hour has double the braking distance. Ratio between 50 and 70 is the square root of 2. You know, so it all goes with the areas. Yeah, some people will smile. The other ones who've done their driving tests relatively recently. So that because this is a velocity, it's a velocity time graph. The area under it is the distance covered, or the temperature here. So the area under that is future warming. And if we can get emissions down that fast, we can limit. If we can get the warming rate down that quickly, we can limit future warming to 1.5 degrees, because that's 0.5 degree. That area represents 0.5 degrees. I went to the next step too quickly there. Another line here, which you can't see very clearly, but that's this dotted line here, is the annual emissions, which you'll notice strikingly tracks the annual rate of warming very accurately. So that tells you very simply what we have to do to solve the climate problem. We have to get emissions to zero before global temperature exceeds 1.5 degrees, which means getting emissions to zero within the next 40 years or so. That's sort of all set by geometry rather than scenarios or models. And one of the things I regret actually in the 1.5 degree report was that in that first summary for policymakers figure, one delegation insisted that we put modelled pathways all over it. They want to put in the word modelled. And if you go back and look at the report, you can see the word modelled appears all over this figure. And sort of with hindsight, I was thinking back and saying, well, it's not really a model result that we have to do this. It's a geometric result. And ironically, it was the delegation, given that that particular country sort of largely invented geometry, it was a very good thing to have pointed out that actually it was geometry that was constraining us here. You know, if you're doing this and you need to do that, there's nothing much else you can do. You've got to bend the curve rather quickly. So I think this idea of a braking distance is quite a helpful one because it's set by where we're at, by the trajectory we're on, and not by any particular scenario. So it's a useful device to use to discuss the climate challenge. It is, of course, uncertain. If you hit the return, we've got, I need to stand over here. So we might be warming faster than that best estimate, and if we are, and we can only brake at that sort of rate, we could easily be committed to another degree of warming. So if I was saying a best estimate, half a degree, reducing at that rate, could easily be 1 degree, and if you hit the return, of course, we don't know how fast we can reduce emissions. So importantly, it might take us much more than 40 years to get emissions to zero. We've never really tried to reduce emissions at that rate. Well, we've never really tried to reduce emissions full stop. And of course, if you can't reduce emissions that fast, then you're committed to a larger integral under the curve in future, and therefore a larger future warming. Let's keep going. So that's what geometry tells you. Now let's look at what the report says about what individual scenarios suggest might be possible to get us on these very ambitious mitigation pathways. The 1.5 degree report showed 4 illustrative pathways of emissions that would achieve 1.5 degrees by 2100 with a pretty high level of probability, between 50 and 66%. So, you know, giving us a pretty reasonable chance of getting temperatures at least back down to 1.5 degrees by 2100. These are the 4 pathways that were highlighted. And we pulled out 4 pathways to illustrate that there were different ways you could combine different measures in order to achieve that climate goal. But what I'd want to particularly focus on, because everybody did focus on it as soon as the report came out, is this P1 scenario, which is distinctive among the 4, because you'll notice it doesn't contain any yellow. The yellow on these, you can't read the labeling here, corresponds to artificial re-extraction of CO2 from the atmosphere or from the flue gases of power stations by either carbon capture and sequestration at source or bioenergy with carbon capture and sequestration where you grow trees and then burn those in the power stations and capture the CO2 and bury it underground, which of course gives you a net negative CO2 emission. So the crucial difference between this scenario and all the other ones assessed in the report is that this P1 scenario did not rely on carbon capture and BECCS in order to achieve the 1.5 degree goal. If we hit return, and I would argue this is the most misunderstood scenario of the IPCC report. Just to give you the source of it, hit return. This is the paper that it's based on. So a single paper, a low energy demand scenario for meeting the 1.5 degree target and sustainable development goals without negative emissions technologies. It was a very specific brief that the authors of this paper gave themselves. They wanted to see if it was possible to achieve the 1.5 degree goal without resorting to carbon capture and sequestration and or subsequently carbon dioxide removal. Hit return. So I think that although this scenario is very widely cited, and particularly by environmentalists, and I'm sure if you had to pick a scenario of the future, that many of those demonstrating school kids would say, this is what we should, this is the pathway we should be on, this is the best scenario, as it were. And so I wanted to highlight some of the dangers of the scenario itself, not the future it describes, but its existence as a scenario. Hit return, please. So this is essentially what it says. If we reduce per capita final energy demand by more than 33% in a decade, the decade of the 2020s, and that's always that per capita final energy demand in the world, not just in rich countries, that's been going up very consistently ever since the beginning of the Industrial Revolution. So and we reduce it by a third in the 2020s. This isn't a number out of the scenario, by the way. This is me taking ratios of other numbers and working out what it actually means. We also have to halve per capita agricultural methane emissions in a decade, which again could be done with a major change in global diet. And reduce CO2 emissions to zero by the 2050s, then we can still meet all our sustainable development goals and limit future warming to only 10 to 15 years of warming at the current rate. Now, if all that's true, if you hit return, we're only apparently committed to another couple of tenths of a degree of warming, which is less than what's happened since I started working with David, really. If you hit return, that's one way you could conclude from that. Everybody can relax because we can switch off global warming anytime we want to. I don't know whether any policymakers are considering this scenario in that light, but that would be a perfectly reasonable interpretation of that scenario. And I think it's very dangerous to suggest that that's a possible future. So let's go on to the next slide. So how should we use these model scenarios? By the way, I don't think it's what the scenario builders themselves would say. That they would say this was as it were, a thought experiment to see what was possible. And they basically what they found was it was possible for their model to come up with a future, and this was the future it came up with, to show the conditions under which you would be able to do without large-scale carbon dioxide removal. But it's now, gone into the global policy thinking on climate change as, not just a possible future, but a very desirable future. As many people, certainly in Europe, are citing that scenario as evidence that we should no longer bother to put public money into even research into carbon dioxide removal, because we don't need it. We just need to reduce demand.
How was it included then?
It was in the literature, and that's the brief that the IPCC report has. I mean, it's not just it's not a blind assessment. So it was an assessment of what was possible, and it was an assessment of what the authors collectively thought was reasonable. I should stress, my views were one end of a range of views among report authors on this scenario and what it was likely to do. And to some extent, my views on this scenario have hardened up since the report came out, when I've seen how much focus it's got. If it was one of 50 scenarios, or even just one of 4 scenarios, why not? Let's see what's possible. The problem is, people have grabbed onto it and said, right, this is it. And this shows we don't need to bother with all that CDR stuff for climate change. And that's what's worrying me. So to some extent, could we have anticipated that? Should we have anticipated that? Maybe we should. I'm a co-author on the report. I'm not suggesting that we got everything right. There was no option but to include it, because this was it was a peer-reviewed paper study, and it was perfectly reasonable what the modeling group did to generate that scenario. But perhaps we could have done more to sort of anticipate how it might be used, and perhaps put more sort of guards around it. I don't know. I'd be happy to talk further about that. And particularly there's people here who actually work with integrated assessment modeling. So how should we interpret these model scenarios? Well, so I like this quote. No talks complete without a quote from somebody important. Future depends on what we do. And so the point is, just because people have made an integrated assessment model produce a scenario return, it doesn't mean that's a possible future. You know, whether it's possible or not depends on decisions that get made in the next few years as to what kind of 2020s we're going to have in return. And in fact, some of the strongest results coming out of the integrated assessment modeling work is actually the failures. These don't appear on the IPCC diagrams because those lines don't exist. These are the results where basically the quote in the paper is always model fails to converge, which means in the sort of the sim world, sim earth world of integrated assessment modeling, it means everybody dies. Because you know, basically you couldn't find a solution for the global economy which kept everybody fed, which achieved a particular climate goal. And crucially, if you return, we find, and this is where I think this really ambitious scenario really does have some useful information in it, no model, no scenario in the entire 50 odd scenarios considered in the 1.5 degrees report shows emissions falling faster than 2 billion tons of carbon dioxide per year. So it is per year because that's a deceleration rate. That seems to be a pretty hard constraint. And that's something we can pull out of these scenarios and consider what the implications are. If you hit return. So just to illustrate that, that's the P1 scenario and the P4 scenario. P4 is the sort of NDCs followed by action scenario where we basically don't really do very much until 2030, and then we try and reduce emissions as fast as possible. And if you just hit return, that's the rate of reduction we see in that P1 scenario. Hit return again. It's much the same maximum rate of reduction we see in the P4 scenario, just happening a bit later. But that maximum gradient seems to be a hard constraint because the models don't seem to be able to get emissions down any faster than that. What that means is, if you hit return, if we're to limit warming to 1.5 degrees by 2100, every ton of CO2 that's dumped in the atmosphere before reductions begin is a ton that will have to be scrubbed out again at some point this century. So just because the P1 scenario exists doesn't change that fact because we're not on it. Emissions are rising. The emissions rose last year. So that's, in my view, the right way or a better way to interpret these scenarios. They tell you something about the constraints on the world economy, on impossible futures, not possible futures. So a future in which emissions fall faster than 2 billion tons of CO2 per year, that's an impossible future. And because even if we reduce emissions at that speed immediately, we still end up at 1.5 degrees, that tells you something about our future committed warming. And therefore, as long as we're not doing that, we're building up a commitment to remove CO2 in the future. So, if you hit return, oh, there's the commitment. See? All that CO2 going in, as we continue not reducing emissions, the CO2 that will have to come out again in the second half of the century. So I think interpreting the P1 scenario as evidence that we don't need CCS and CDR, carbon capture and sequestration and carbon dioxide removal, is exactly the wrong interpretation. Let's keep going. So this is the sort of argument that keeps going. This is the technology we're talking about, capturing CO2 short term from power plants, re-injecting it underground. Later on, the fuel going into these plants might be from bioenergy, and therefore that would be net CO2 removal from the atmosphere. It remains massively unpopular. It was killed off in Germany by the kind of demonstrations that say, it's going to poison you in your beds. It's still, there were demonstrations saying keep it out of the whole climate process regularly at COPs. Kids, keep going. But if we actually look at what's going on, these are the emissions committed from electricity power plants built before 2017. So if we just run those power plants for the existing power plants for their natural lives, these are the emissions that end up in the atmosphere. You can see, so the lines obviously go up because we were building new power plants, and then they go down after 2017 because the older power plants get pensioned off and closed down. Hit return. By the way, that just shows you where they are, and notice most of that very rapid increase occurred in Asia. It's remarkable. So between 2000 and present, there's been like a trebling of CO2 committed emissions from CO2 power plants in Asia. Keep going, David. So that shows you, sorry, if you go back to the previous one, back to the previous one, sorry. So notice these, if we just stopped building power plants now, fossil fuel power plants now, we would see emissions coming down naturally to reach zero around 2050 or so, the lifetime of a power plant coming in there. But that, of course, is not what's happening, and if you hit return, this is globally, including now plans and power plants under construction, not even including power plants that I've been hearing in the past couple of days are being proposed for construction by certain governments not far away from here. So these are globally fossil fuel power plants that are already part of national energy plans, and if you hit return, that's this grey area is essentially what we can afford to put in the atmosphere for generation purposes, electricity generation purposes, if we're going to limit warming to 1.5 degrees, and so that is clearly excess. So the path we're on is not that P1 scenario, and every year we're staying off that scenario, we're building up that commitment to future carbon dioxide removal. Keep going. So this is how I think we should be interpreting these model scenarios. Keep going. We can only do without CCS CDR if we reduce global energy demand very substantially by 2030. We're not doing it. We're not even trying to do it. We're not even planning to reduce demand. And so we need, if you hit return, we need CCS CDR. We need this technology to get CO2 back out of both emissions and to get CO2 ultimately back out of the atmosphere. I was going to talk a little bit about how one part of the fossil fuel industry is thinking about this. I think we might, this is the Shell Sky scenario, but just thinking, watching the time, I mentioned it's wrapping up. Let's bleed over this Sky scenario because you kind of got the general picture. We've got to, let's stop there. So Shell in their Sky scenario, interestingly, the fossil fuel industry are sort of grappling with this and seeing how it would be technically feasible, how they see it would be potentially technically feasible to actually transition to a future in which every ton of carbon dug out of the ground is balanced by a ton of carbon being sequestered. And what they don't do in this scenario, and it makes very interesting reading, you have to read it carefully to spot what's not there as well as what is there, is tell us what policies are actually going to be used to achieve it. But one thing they do say is that we need a carbon price, and people like carbon prices. They're very sort of a popular policy measure. They're apparently not so popular. I think these are Australians, by the way. Let's keep going. But when you actually look at the carbon prices that are required to achieve these goals, so this is a figure that was not in the 1.5 degree report, although I was quite keen for it to be there because I think it's quite shocking. These light blue lines here are the scenarios that achieve 1.5 degrees. Okay, they involve carbon prices going, in some cases, north of $100 per ton by 2020, going up, into the several $100s per ton by 2030. This is a log scale, heading up to thousands of dollars per ton by the end of the century. That's what it takes in these models to price carbon out of the system. Nobody's suggesting that's this is again like, you should be careful how you interpret results from these integrated assessment models. This is not a prediction of the future. In the context of the constraints of these models, this is what it takes to get emissions to zero, relying on a carbon price. And I think what this tells you is, we're not, well, I think from the experience in Australia, is that we're not going to get emissions to zero relying on a carbon price. And increasingly, I think even economists are starting to recognize that. Okay. So just to sort of wrap up, since I've sort of, it's easy to, I like this quote as well, any fool can criticize, condemn, and complain, academics love sort of grumbling. Can I come up with a better idea? Carbon pricing isn't working and doesn't look like working. So what alternative approach could we take that might be effective in addressing the climate issue, which might be more effective than relying on carbon price, global carbon price? Here's an example of a climate policy that does work. It's essentially performance standards, performance of US fridges. Okay, this was not based on pricing. Consumers generally have no idea what they're spending on the energy used by their fridge, but by imposing performance standards on manufacturers of fridges, the US government got the energy use of fridges down dramatically between the 1970s and the 2010s, while at the same time the volume of US fridges, I think that's the cubic meters inside them, not cubic kilometers inside them, can continue to go up. So, an example of a successful story, if you can work out sort of, if the US had still been using 1970s vintage fridges in the present, it would probably make even more eye-watering emissions. The same goes for car efficiency standards. Again, it's auto efficiency standards, the same kind of story there. It's the main driver of reducing emissions. And the same goes in Europe as well. Well, Europe loves to talk about their emission trading scheme and the role of carbon pricing in reducing emissions. Thinkers like Michael Grubb have actually looked very hard at the data and come to the conclusion that actually the price-based mechanisms have been largely irrelevant. Certain outside, very specific, highly monetized and sectors like certain sectors of the electricity generation industry. By and large, emissions have been reduced by regulations and performance standards. So, next slide. So that's just where I came from. So what performance standard could we come up with for the fossil fuel industry that would actually get us to net zero? I'm sure some of the demonstrators here would suggest this performance standard, but it's difficult to sort of say that your performance standard for an industry is the industry just crawls away and dies. So you've got to come up with something else. I think that it sort of behooves us to think of what exactly are we asking the industry to do to be compliant with a net zero world. So let's go to I think there are clues in these integrated assessment scenarios. Here's going back to the scenarios again, looking at a larger family. These are the well below 2 degree scenarios, not just the 1.5 degree ones. If you ignore the bright blue line here, just focus on the colored lines. These are the traditional scenarios. These ones start in 2010, but it doesn't matter, they tell us the basic picture. The colors show the money spent on mitigation, climate mitigation, in individual decades over the century, and the grey area here is when CO2 emissions go below zero, so become negative emissions, net CO2 removal from the atmosphere. And as you can see, most of these lines, they cross zero in the second half of this century, sometime between 2060 and 2100. That's because these are the sort of well below 2 degree scenarios considered. You hit return. That's a sort of, let's try and sort of deconstruct that rather messy spaghetti diagram to see what this means. And this is a nice way of sort of framing the problem. So one of you in this room will have endured hearing me talk about dynamical systems. And did you use the chaos option? Where is it? Where did it go? Anyway, no, you didn't do that one. Okay, so he hasn't even. But one of the things we like to do in physics is to draw sort of how the rate of change of something varies with the quantity. Yeah, so we've got rate of change of global temperature in the vertical here, and global temperature in the horizontal. And right now we're here, about around A. So we're at 1 degree, and we're warming at a fairly constant rate. So we're moving in that direction. Yeah. So this is the rate of warming, this is the warming. So we're moving along there. If we're going to limit warming to 1.5 degrees without an overshoot, we have to get to here. If we want to limit warming to 2 degrees without an overshoot, we have to get to there. So again, there's not very many degrees of freedom in that problem. You're starting off flat, you've got to bend the curve round and reach the zero line, either here or there, depending on what temperature you want to stabilize at. Okay, so it kind of simplifies the whole problem. You don't need an integrated assessment model to say this. This is just true. You could come up with a more elaborate scenario, which sort of does that. Okay, but it's more complicated. This is the simplest way of doing it, and of course that would involve an overshoot. It would involve going past 1.5 degrees and then coming back to it. Okay, I do that, but I produced this this afternoon, and I couldn't. My Excel skills extend to doing that, so you have to imagine that. Left as an exercise. Moving on. Okay, so you can say this about the rate of warming. But remember, because carbon dioxide accumulates in the climate system, the rate of emissions of carbon dioxide is proportional to the rate of warming that's caused by carbon dioxide. So if you hit return, oh, no, sorry, go backwards. So you may not have noticed that David hit return at that point. So this is, go back one, because this is the point. So that's the rate of human-induced warming here. Hit return. That's the rate of CO2 emissions. Okay, obviously the graph looks exactly the same. Yeah, because that's another statement of what we have to do. We're emitting at 40 billion tons of CO2 per year. We're going up slightly, but okay, for the sake of a nice simple diagram, let's say it's horizontal at the moment. It's got to come down to zero, and it's got to come down to zero by then. And if we're not going to overshoot, it's got to come down in monotonically. It can't sort of spiral around. So again, the future is constrained by geometry, not by any model. So what does this mean? Return. Here's another way of putting it. This is the fraction of carbon that we dig up that we re-inject underground, or the fraction of carbon we burn that we sequester. That has to get to 100% by the time global temperatures reach 1.5 degrees, in this case, or 2 degrees in the blue line. Okay? You could wiggle that line if you wanted to, but that makes it more complicated. In the end, that's basically what you've got to do. If you could delay, and then you've got to go up even faster at the end, but it doesn't make any difference to the overall trajectory you need. And given at the moment, we are not sequestering anything, and we're not increasing the rate at which we sequester at the moment, because we're basically flatlining right now in this area, that's how you're starting. So that constrains your shape. It's starting horizontal, it's got to get to a target. This is the simplest possible trajectory. And that's important because we'll use it again in a minute. Hit return. So this blue line is a scenario in which, so we didn't run an integrated assessment model, we simply said, we need to get from A to B, we need to increase the fraction of carbon we sequester on average by 10% for every 10th of a degree of warming from now on to reach 100% by the time temperatures reach 2 degrees. That's again just a mathematical fact, because we're at 1 degree now. You need to increase the fraction you sequester by 10% for every 10th of a degree, and you'll get to 100% by the time temperatures reach 2 degrees. If you want to get to 1.5 degrees, you just got to increase by 20% for every 10th of a degree from now on. Again, these are just mathematical facts, not based on any model. And that gives you this pathway. Now I've plotted it against time, so it no longer looks like a quadratic, because of course the global warming slows as we approach the limit. And it gives you what it would take to stay on the safe side of this plume of scenarios. Why do I call that the safe side? Well, if you hit return, David, you'll notice here these colours sort of sort themselves out a bit here. And the dark red lines, the scenarios corresponding to the most expensive futures, the futures in which we are spending more than the value of the world economy in the 2000s on climate mitigation alone in the latter part of this century, those are the scenarios in which we've failed to develop CCS and CDR. So, you know, this is the future we don't want, because the chances of that money being spent to meet those climate goals at that point, well, it's a big challenge, it's a big ask for the next generation to expect them to spend that sort of money, because we've failed to develop the technology that they need to avoid spending that money. So, hit return. So that's what, you know, that assuming just a quadratic increase of the sequestered fraction with warming as we go forward into the future gives you the blue line and keeps you away from that danger zone of leaving the development of this technology too late and having to resort to ever more expensive measures in order to reduce emissions. Return. So this is what a scenario for progressive deployment of CCS might look like. We're now at 0, hit return. We could aim for 1% by 2020. I've been doing this talk for a couple of years now, and that's probably looking a bit hopeless, but you know, I'll keep saying it. We could still do it if we had to. Hit return. 15% by 2030 is probably still within the realms of possibility. And of course, what you need to do if you're going to actually meet our climate goals is hit return 100% by the time temperatures reach 2 degrees, or before then, if we want to limit warming to well below 2 degrees. Hit return. So let's think about what this would actually look like as a policy, and crucially, what it would cost. So if you simply told the fossil fuel industry to start disposing of CO2, how much would it cost them to do it? Well, they'd find obviously cheap CO2 to dispose of, and they'd find the cheapest possible ways of getting rid of CO2, and the industry itself claims it can do it for around $50 per tonne under ideal conditions at the moment. Let's, as it were, call their bluff and say, okay, if you think you can do that cheaply, then this is what increasing that sequestered fraction would cost as a function of actual carbon used over the next few decades. To start with, sort of 1% sequestration would be the equivalent of 50 US cents or so per tonne of carbon used. It would be completely negligible because, of course, you're dividing the cost of sequestration by 100 because you're only sequestering a small percentage of the carbon you dig up. By the mid-2020s, by the 2030s, you'd be looking at, you know, a sixth of the carbon we dig up being sequestered. That would be extraordinarily ambitious compared to most scenarios for CCS deployment, and that would cost only $12 per tonne of CO2 actually used. Of course, by the time you get to 100% sequestration, you know, later on in the century, it all becomes very expensive because then you'd be talking about recapturing CO2 from the atmosphere. Because the last applications of fossil carbon you use, things like jet fuel and so on, are probably applications in which you wouldn't be able to capture the CO2 at source and have to recapture it from the atmosphere. You know, people like carbon, what's the name of the company? So David Keith's company. Help me out here, somebody. There's a company, Carbon Engineering, in the US that claims they can already capture CO2 from the atmosphere at scale for $200 per tonne of CO2. It's a paper claim. You know, what we need is, you know, large, deep-pocketed investors saying, now do it. And then we'll discover if this company still exists after it's been trying to bury CO2 for $200 a tonne. If it still exists after 2 or 3 years, then we'll discover that it's probably right. And the owners of the company, deservedly, will become very wealthy. If it can't be done for $200 a tonne, then the company might go bust. And we will discover thereby what this actually costs. Keep going. So, these are sort of, to sum up, sort of simple facts to remember. If we want to reach net zero by 2 degrees, we've got to increase by 10% for every 10th of a degree from warming from now on, and that would imply 4% sequestration by 2030. So we're not happy with 2 degrees anymore, hit return. 1.5 degrees means 20% per 10th of a degree from now on, and that implies over 15% sequestration by 2030. That would cost of the order of $10 to $15 per tonne of CO2 used, even if the entire cost were passed on to the consumer. And there is the fact that the reaction of the oil and gas industry was so negative to this proposal suggests that they think that they might not be able to pass the entire cost on to the consumer. That's it, return. I used to say Gorgon was an example of how mandatory sequestration works, in that it was a project where Western Australian state government told Chevron to dispose of CO2, and they said, okay, yeah, we'll do it, without any public subsidy. It's still not happening. Whether it's not happening because, well, reasons for it not happening are not entirely clear, and one hopes that Chevron are going to get adequately pressured by the state government to make sure they actually do what they said they were going to do. But it is evidence that if you require fossil fuel companies to get rid of CO2 as a licensing condition of digging up fossil fuels, they no doubt kick up a big stink about it, but then they do it because that's what they do. That's it, return. So many environmentalists are very uncomfortable with CCS, and many of them oppose many CCS projects, and I think they're right to do so. Because most current CCS projects are basically paid for by taxpayer subsidies. And I can see no very strong argument for taxpayers' money being spent to subsidize the development of CCS, Because if you ask yourself who's the main beneficiary of successful CCS development, well, apart from future generations, I guess, return, it's the owners of the fossil fuel assets themselves. Because then, of course, they can carry on selling their assets in a net zero world. If you hit return, so crucially, if you assume that fossil energy is priced at whatever the market will bear, then the marginal benefits of increased consumption go to the rental, the person digging the fossil fuels up, not the consumer. So it's you know, we tend to focus on the benefits of fossil fuels to the consumer, and we rather forget the fact that most of the benefits of our continued fossil fuel use actually go to the people who own the stuff as it comes out of the ground. So why should her taxes, so to speak, be used to develop technology to allow this, I'm sure it's a very nice guy, to carry on selling his product? Keep going. You may not be aware of it, but in 2015, the United Kingdom came that close to solving the global climate problem. In the energy bill of that year, we had an amendment tabled. There was 2 lines in the original bill. Within 1 year of this act coming into force, the Secretary of State shall undertake a consultation on measures requiring extractors and importers of petroleum to contribute to the development of carbon capture and storage. It was supported by all 3 parties, including by a very strident climate skeptic, Matt Ridley. He stood up, that was a very good idea. He then rambled off about climate sensitivity in a sort of slightly irrelevant way, but actually he had no objection to this. Clearly could have easily carried cross-party support. It was killed. I don't know how it was killed. I don't understand the process of lobbying and things. I do know that I was lobbied about it. I was taken out for a coffee by a representative of Oil and Gas UK who told me at great length what a bad idea it was. And the longer he talked, the more I sat there thinking, this is a really good idea. So he was just doing his job. Anyway, it didn't happen. But if it had happened, you've got to sort of think about what would have happened, what the consequences would have been. The fossil fuel industry itself would have been required to start to take care of its principal waste product. If you hit return. The idea isn't dead. The UK government did its usual thing when it had a good idea, but then it couldn't do it because of lobbying. They created a committee to talk about it. And that committee produced a long report which details a very nice random system, how you could introduce a certificate system to allow companies to take responsibility for the CO2 generated by the products they sold and progressively increase the fraction of that CO2 disposed of so as to put it on a path to net zero, responsible path to net zero by the time we reach any particular temperature goal. It's all there. Return, just so if I've got a couple more minutes. You know, the problem, of course, it was lobbied out. And I suspect if you try to introduce a measure like this in Australia, I should imagine the reaction of the industry might not be entirely positive. So what can we do? What development might actually make fossil fuel companies, or perhaps not the companies themselves, but at least their shareholders and resource-rich and governments of resource-rich economies accept this sort of trajectory, this sort of policy approach to dealing with the climate issue? If you hit return, just an observation, and this sort of comes back to work that's sort of more relevant to many people here, including David. If you release fossil carbon into the ocean, this is, of course, the Deepwater Horizon leak from BP, you're liable for the cleanup and compensation to the shrimp farmers who lose money and the other shrimp farmers who have to work to scrape up the oil. Return, if you release it into the atmosphere, you're not. Why not? It's not obvious to me why not. Return. So, you know, while the industry itself may not be taking liability particularly seriously, there are risks and new developing risks of those investing in the fossil fuel industry. The reputation risk, there's the possibility of liability for climate change impacts. There's the possibility of the assets they're buying or investing in becoming stranded just through innovation, making them irrelevant. And then there's this more sort of technical challenge of the fact that the rents from fossil fuels might in effect be seized by future governments to pay for mitigation or remediation or taking CO2 back out of the atmosphere. And you know, we would argue that a sort of progressive, gradual, but still fast enough to reach 100% before global temperatures exceed 1.5 or 2 degrees, sequestration mandate, sequestration program would address these risks and guarantee that some fossil fuel assets, not all of them, would actually remain profitable even in a net zero world, and give the owners of the industry and those who participate in the industry a viable future. Many of the people demonstrating today probably wouldn't want that industry to have a viable future. To actually saying that back out of that. No new coal. That's fine. I'm all for that one. But what do we do with the coal that's out there? Anyway, so let's keep going. By the way, just in case you're interested, we sort of thought about this for practical measures people can take. You probably own a piece of the fossil fuel industry. We kind of all do. If you have a pension, if your university will have money invested, probably actually Melbourne has entirely divested from fossil fuels, only from thermal coal. Yeah, okay. So Melbourne has selectively divested from fossil fuels. So has Oxford, by the way, on that one, very selectively. So we've thought about, how can investors actually engage with this industry to try and put it onto a path that's consistent with a net zero world. And some ideas on that. There's a little pamphlet on these Oxford Martin Principles for Climate Conscious Investment, which spell out these ideas. We don't really get into the details of sequestration targets and so on, but at least we do want companies to sign up some very simple points. Do they get the idea that we've got to go to net zero? Do they have a profitable net zero business model, so they're not just banking on some kind of bailout? And have they got some medium-term targets of how they're going to make progress to achieving that? Very few extractive fossil fuel companies could actually answer those three questions credibly. And so, but I think it's helpful to push on. Let's go. It's finally. I gave a. I'm proud to say I gave a much shorter version of this seminar to the Norwegian Bank, Norges Bank Investment Management, just a few weeks ago, and about a week later, I'm sure the timing was entirely coincidental, but I would love to take some credit for this. They decided to cut their investments in the oil and gas industry. They weren't allowed to do that for environmental reasons. They justified it because they perceived the potential downside risk of owning fossil fuel assets when it was a country that was also dependent on oil prices itself were unacceptable to the fund. And I think that's, that suggests a way in which potentially through investors, through engagement with these companies, we could potentially make this future a reality, but it's going to be a long haul. Thank you.
I'm now powered up. We have an audience through the webinar. If anyone's got questions through the webinar, if you can send your questions as very, very concise questions through the chat function in the webinar. Otherwise, if we've got any questions from here, please raise your hand. And I'd much prefer to have a particularly ungender biased group of questions. So, over here.
Thanks, Myles. That was really interesting. I didn't mean to ambush you with that question.
No, it's a good question.
I've just got stuck on this idea of the IPCC report failing at its job. You spent so much time. I know other people doing IPCC now. They're losing nights. They're hours and hours and hours on this report, on these graphs and on these documents, only for them, for you to feel that they were being misinterpreted or being misused by both sides. What can we do? What can IPCC do to stop that from happening?
I don't think you can proof, if you made these reports impossible to misquote or misinterpret, they would contain nothing. I'm afraid the responsibility lies with all of us, particularly the communicators who are out there in the media after these reports come out, to push back on the misleading messages. Because I think that's, whatever we say, people will pick out what they want. Townsend's article, which that Daily Mail reporter went nuts on, it was a perfectly reasonable article. She didn't headline it, doomsday prediction, totally wrong, factor of 7 out. They went through the article, they found those numbers. They're out there doing this. That's the reality. We can't write our articles and our reports to make it impossible to do that. We've just got to engage and make sure that these misleading messages don't self-perpetuate. And what worries me at the moment is there doesn't seem to be any pushback on this 12 years till doom story. It keeps propagating. You know, I hear it from my own kids. And then they come in and say, is it true that IPCC report said it was only 12 years before the world comes to an end? Well, I didn't say the world comes to an end, but, you know, and it really worries me.
In the middle here. Yep.
Yeah, cool, great, thanks. Cheers. Thanks, Myles, fantastic. Really great sort of exploration of the issue. On that last point, it's a framing issue. I'm in the business of trying to convince corporates to do something about climate change. So,
Good luck to you.
Positive and negative framing. I think the 12 years to do something works when used strategically.
Sorry, 12 years to do something is correct.
Mm.
12 years to doom if we don't do something is misleading.
Correct.
It's not necessary. It might be correct. Well, let's hope it's not. But it, you know, and what I was particularly unhappy with was Alexandria Ocasio-Cortez, because she claims to be on the right side of this, and also clearly understood it because she neatly twisted what was said to make it more defensible, rather than just addressing it and saying, actually, you got that one wrong, they didn't say that, but here's something else, which is important.
Correct, and we're using it as a call to action and urgency.
Yeah.
You've got this time to do this thing. On that, this, the piece you presented today is highly predicated on CCS being a functional economic technology. Is it that today? Because I haven't seen any evidence of that.
At no point did I suggest it needed to be economic. Okay? I did. Okay, and also at no point is it's not up to us or me to prove that it works. It's up to the fossil fuel industry. They're counting on it. Shell's scenarios are full of CCS. Whenever you talk to anybody in the fossil fuel industry, it's going to happen somehow, and somebody else is going to pay for it. Well, they don't say that, but that's the subject. So the importance of this approach is they've got to be put on the spot and say, look, prove it. You're relying on this. The future of your industry depends on it. Make it happen. Nuclear waste disposal is not economic. We don't make an economic case for nuclear waste disposal. We just do it. Actually, we don't do it as well as we should. So that's probably not the best of analogies. But there's plenty, you know, we don't really address waste disposal problems by asking, is that waste disposal process economic? We just say the waste has got to be disposed of, now do it. And if you can't do it, if your activity becomes completely unprofitable because of the cost of disposing of the waste, then that's bad. That's tough for you, but that's just what happens. And of course, it may well be that many of the applications we currently make of fossil fuels become uneconomic when you include the cost of disposing of the CO2. That will almost certainly happen.
Thank you, that's very helpful.
Another question from the left wing over here.
Yep, the left wing, exactly. I think you're putting a lot of faith in CCS, and I think your framework is basically business as usual, tweaking the system. And climate justice activists, and not just the ones that want renewable, but the ones that are a bit more radical, basically say, not climate change, system change. And I'm an anthropologist, and I've been thinking about this for some time, for about 12 years. And for me, we have to start thinking of moving beyond the existing system. Now, that's not a very popular position. That's not a position that the fossil fuel industry is going to want to take on. Neither are governments. We're at that juncture.
A question or just a statement?
So what do you make of the argument that climate justice activists say? Not climate change, system change, radical change.
So I accept that this is potentially an attractive future for the fossil fuel industry, more attractive perhaps than the possibility of them being, forcibly shut down, which you could argue is the sort of the only effective alternative. The problem is, if we simply say we want the fossil fuel industry, if the alternative is the fossil fuel industry simply dies, then as long as it's not dying, it's being completely let off the hook. And the difficulty we have with our current scenarios is there's a strong risk that if we continue on our current trajectory, that's 40 billion tons of CO2 per year being dumped in the atmosphere that we're assuming our kids will scrum out again in the second half of this century. We're investing nothing in making it possible for them to do so. So we're imposing the entire cost of that CO2 removal on the next generation or the next generation but one. What this proposal would do would be to require the beneficiaries of our continued use of fossil fuels today to pay for some of the cost of that CO2 disposal. So that's, to me, there's a very strong justice argument for that. And there's a really terrible injustice in just allowing the fossil fuel industry to carry on while screaming that it should stop and failing to actually make any impact on it. We're still increasing our use of fossil fuels.
We've got a question online from our webinar online audience.
Yeah. So I was at the school strike this morning, so apologies for my voice. This comment comes from Scott Power. It says, great talk, thank you, Myles. To clarify, can you please go over again why you think CCS and CDR are crucial? And in particular, is it the plot that shows the costs without CDR and CCS become prohibitively expensive at the end of the 21st century?
That's the economic case for it, if you like. And the reason those costs become so high, if you don't have it, is because it's the lot, but CCS and CCR, because they're so expensive, they're the last thing you do. And if you don't have that available, the only other thing you can do to reduce emissions later on in the century is just simply reduce demand, forcibly reduce demand, basically require people to use less. That, from an economist's perspective, is the most expensive climate measure, and from many politicians' perspectives as well, will be seen as the least acceptable climate mitigation measure. The reason, so that's the economic argument for why they're essential. The more sort of immediate, obvious argument is the simple geometric one. If we reduce emissions as fast as we can now, then we get to 1.5 degrees. We can't reduce emissions any faster than that. And so every year we're not reducing emissions, we are committing a future generation to bury 40 billion tons of CO2. That's just the rate at which the commitment is building up. So that would be actually, in my view, the stronger argument for why we're committed to this technology, because we're not reducing emissions. If we were reducing emissions by 2 billion tons of CO2 per year, then I'd say, yes, we probably will be able to do without this technology. But until we're in that situation, we've got to accept the fact we're going to need it.
Or planet warms more.
Or we miss our climate goals. That's, of course, the third one. The point is, we're starting here from the premise that we are aiming to meet the goals of the Paris Agreement.
Some countries are.
Well, I believe even Australia is notionally goals of the Paris Climate Agreement.
Glad you're optimistic. We have time for one more question, and given that we've had the left wing, I'm going to take one from the right wing.
Oh, I'm on the right wing, great.
I'm from the front.
Thanks very much for the presentation. I'm a PhD student at Stanford, visiting here at the college, working on state-owned enterprises and the reasons why they adopt clean energy technology or not. So I'm going to ask a horribly self-interested question, which is about your proposed solution and the licensing recommendation. Because it strikes me that given the very pervasive extent of state ownership of fossil fuel and their management of those assets, I was wondering whether you've given any consideration to the differences between state and private firms and what that might look like in the US.
Yes. So clearly a regulation like this, if imposed on only a single company, would just drive that company bust and wouldn't really achieve anything then whatever that company was digging up would be stirred up by other companies. And therefore the existence of state-owned companies who might not be willing to comply with a regime like this presents major challenges to the idea of sort of implementing something like this and rolling it out globally. But that said, I think there are some attractions to this idea because it works like a performance standard. You could certify fossil fuel as compliant with this regime or not. And you could then go downstream and say anybody manufacturing anything, anybody using anything, any country importing fossil fuels has a choice whether they buy compliant fossil fuels or the rogue stuff. And that actually works quite well as a way of propagating a standard through the world economy. We've seen that work in other areas, and it allows a relatively small number of players to end up calling the shots, just as Californian vehicle emission standards effectively set the standard for the US, because nobody wants to have to sell a different vehicle in California to what they sell in the rest of the US. If enough countries and enough companies just agreed that they would only buy fossil fuels from suppliers who are compliant with this regime, then it might be that even the state-owned enterprises would say, well, right, we don't believe in climate change, we think this is all a load of rubbish, but we want to sell our product, so we'll just comply. You know, that means they don't actually have to buy into any particular ethical, moral case for climate change. They just want to keep selling their product in the world where people demand it.
Myles, I know you're like me. We can both talk underwater non-stop for hours, but the audience may not be prepared to stay for as long as you can talk. And we need to also recognise that Myles actually got up well before 5 o'clock to fly from Canberra to Melbourne this morning after talking to people in the Department of the Environment and Energy.
They weren't very convinced about this in there either.
So enjoying that.
It was worth a try.
What I'd like to ask you all to do is to join me in thanking Myles. This talk will be recorded, or has been recorded, will be available, including even some of the stuff. We may not have even told you that it was being recorded, but that's okay.
I haven't signed a release form.
I know. We ignore those.
Okay.
Please join me in thanking Myles for a fascinating talk.